So the title is just a small core dev living in the layer 2 world. So I have been working on looking at layer 2, coming from a layer 1 background in the last year. So like, I just want to share some learning, something exciting that I have been thinking while looking at layer 2. The goal of this talk is just to get everyone as bullish about layer 2 as possible. So yes, hopefully it will work out. So let's see, how do I change slide? Press. All right, so the agenda is I want to go through my journey from layer 1 to layer 2. I want to talk about layer 1 and layer 2 trade-off, what makes sense, what doesn't make sense. There are some like common fallacy out there that I kind of want to like talk a bit on. And then I want to get into the fun part. How does layer 1 supercharge layer 2? And then like a little bit of forward thinking, what I think layer 2 will become in the next few years. So trying to find where to press the button. Okay, maybe I need to press over there. Okay, so this is the little journey that I have gone through from my personal life. So I started working on this space since 2018. I found the co-founders on working on Prism at early 2018. So we started working on sharding. And then we're working on sharding through smart contract, which didn't really make sense back then. And then we jumped to proof of stake. So we spent the first 2 years working on proof of stake, the Prism client. So they kind of taught me how to write production software because like Ethereum is secure by $200 billion. So that's a lot of money. We need to write secure software. And then back in 2022, I worked on the merge. And then towards the later half of the year, we were fortunate to join the Offchain Labs family. So we formed a very good team. And then I started looking at layer 2. So I began looking at very interesting problem on layer 2. In parallel, I work on 444 data sharding. And then I look at the next proposal builder separation design, basically on the layer 1 and also layer 2. So this journey kind of like hopefully illustrate like how I spend my time, right? So I'm kind of in this very unique position that I look at layer 1, I look at layer 2, and I look at the MEV across the landscape. So this is kind of just like, kind of just to illustrate where I am coming from. So let's quickly talk about layer 1 versus layer 2 and how they're fundamentally different. So layer 1, like you have this consensus actor. So you have your validator, you have your node, and the validators is this like party. Basically, they have a stake in the game, and they're the one that's driven the chain. They're the one that governs the consensus. When we use a blockchain, you typically look at the validator, you look at, okay, how secure is the chain? And validator kind of tells you the whole picture, right? So for now, Ethereum, you have 700,000 validators, and then you probably have another like 100 in the pending queue, and then about 32 ETH per validator, and then about 20% of the ETH is staked. So to break Ethereum, you probably need a lot of money, yeah? You probably need 33%, you probably need $50 billion to break Ethereum, right? On the other side, you have just node, basically. They are altruistic actor, basically. They run nodes for fun. They could run node for their dApps. They could run node for a lot of things, right? But they're free to run. But typically, when you run a validator, you also have to run your own node. But you can run a node with or without validator. So here is the layer 1 consensus in a nutshell. So sorry that like I'm talking about layer 1. I know this is a layer 2 event, but I promise you this will I will get to the whole picture very shortly. So layer 1, you have two type of 4-choice rule. You have your LMD ghost, which is a normal 4-choice rule, and then you have your FFG, which is kind of your finality gadget on top of your 4-choice LMD ghost. And this is why Ethereum is beautiful, because you have this type of overlay mechanism. So you have liveness, you also have safety, and you can play trade-off there. But the downside of that is that it's very expensive because we want maximum decentralization, yeah? So that means that every validator has to make a vote at every epoch, which is 6.4 seconds. And there is about 1,800 messages per second. That's a lot of overhead. But this is okay because Ethereum is maximized decentralized. And then to run the Ethereum node to stake, it's not easy, right? If you really look at it, you have your consensus layer client, you have your execution layer client. Then if you want MEV, you run MEV boost, you talk to the relayer. And then if you're a validator, you also have to secure your key to prevent from getting slashed, blah, blah, blah. And then you have to make sure your node is up, alive, performant, otherwise you will lose money. So layer 1 reaction, this just illustrates like running the node is not as hard as it is, and then hopefully this will become easier in the years to come. So decentralization has a cost. This is what I'm trying to get to, right? Because we want maximum decentralization, Ethereum made the trade-off to have multiple client implementation. You have 6 consensus client, you have 6 execution client, right? There are all different languages. And this is great because if like Go has a language, then people can switch to the Rust client. If today I wrote a bug, someone else can use others client. So you have this maximum uptime. But the downside is it's very expensive, right? A lot of those clients use grants, a lot of those clients are publicly funded. So therefore, that's a lot of budget for all the client teams. Also, Ethereum adopted this rough governance model, meaning that like it's not a bureaucracy, it's not coin voting. So every decision go through a very rough governance period where like developers, community members can jump into the HCD or core dev code to voice their concern. If there's no hard no, then go in. But the downside of that is just that like you cannot have that many feature that going every year. You have 1 to 2 big feature per year, right? If you look at it, right? We have the proof of stake chain. The second year we have light client, we have Ether. The third year we have the merge, and then we have the withdraw, and now we have 4844. So there you can only have one big feature every 8 to 10 months, and that's unfortunate. I mean, it is unfortunate, but that is decentralization, and that is a trade-off that layer 1, especially Ethereum, is willing to make. Okay, let's quickly look at the staking distribution up to date on Ethereum layer 1, right? So now you have like 33% on Lido, 33% on just a bunch of exchanges. Then you have your unknown. There are whales, there are people that have lots of ETH, they're staking, right? So there's, I mean, it's not bad, but it's also not ideal because like Lido can come together and do something malicious, and then there's not much we can do with it unless we do some sort of like social slashing, blah, blah, blah. So it's not great, but it's also not bad. Okay, so this kind of sets the stage for layer 2. So everything I said before was layer 1, so let's jump to layer 2, right? So layer 2, what I want to get to is fundamentally very different than layer 1, right? So layer 2, instead of a validator, you have sequencer, and you have proposer, which some people call them validators. So they are interchangeable, right? So you split the validator role into sequencer and proposer, right? And they're fundamentally very different by actors, right? So sequencer, all it does is that it orders transactions and then it emits a feed, right? It's very important to know that sequencer cannot steal. Sequencer can only order your transaction. Sequencer can also not censor you because you can still submit your transaction through layer 1, right? So there's something that sequencer can do and cannot do. And then on the other side, you have your validator and proposer. And then proposer essentially proposes a layer 2 block using the sequencer feed. And then proposer is the one that, validator is the one that does like invalidate state transition. They can try to exit some invalidated state into layer 1, cash out. That's why for optimistic rollup, there's the 7 days wait period, right? And then like the mentioned earlier, challenge jam, we should be able to reach a permissionless challenge jam fairly soon, such that anyone can participate and the honest party can always win, and the users can always safely exit to layer 1. So it's important to know that they're fundamentally very different, right? When people say decentralized sequencing, and then to me, I feel like decentralized validating is probably more important because like they're the one that can steal your money, right? I mean, sequencer, you trust them to not order your MEV, but if today you have the proof that you see them reorder, you see them extract MEV, you can also like point that out and then social slash as well. So some Arbitrum in action. I'm sure many of you have seen this wonderful diagram already. I don't want to go through it. So you have your transaction, go through the sequencer, and then you have a self-commit. And this is when the users really like you have this very fast response time. And then you batch and compress, you push it onto layer 1. And then this is where, when layer 1 chain finalized, this is where we know we're good as long as you're running like a node, right? And then you have your validator on the other side, with just the state transition function, propose layer 2 block, and then you wait 7 days, and then you settle to layer 1. So this is, I'm sure many of you guys will know this. All right, so layer 2 consensus in a nutshell. Let's compare layer 2 consensus with layer 1 consensus I mentioned earlier, right? So sequencer, it's basically it's an actor that come to consensus on ordering policy. So you have your first come, first serve, which is what we do today, which has a trade-off with very fast latency. But then there's some spamming from back running, which Akaki is working on time boost, which is very great. Now we're going to resolve race by bidding, and that's coming fairly soon, right? And then right now it's centralized, so their participation count is 1. So you have this like 100% life need threshold. But also to be fair, like most of the sequencer, they're very sophisticated actor, right? So they run their sequencer across different regions. They have backups already, right? But when we move to the decentralized sequencing scheme, we're likely going to see an encryption and decryption community, right? So you have this participation count of just 1 to 20, and then you probably need 33 to 50 to be honest, to be able to decrypt the transactions. And then on the validator side, you only need 1 out of n safety threshold. You only need 1 honest validator, and that is the beauty because you have permissionless fraud proof. Right, so let's talk about decentralized where it matters, right? So let's look at layer 1 validator, right? Do we need multiple implementation? I say yes. Do we need multiple people running a node? I say yes. I mean, those two are easy, right? But for sequencer, do we really need multiple implementation though? I would say, yeah, it's probably a nice to have, right? You have something in Go, something in Rust. And then do we need multiple node runner? Yeah, I would say yes, because then you can just basically have like if one sequencer goes down, you have another sequencer, right? But for layer 2 validator, do you need multiple implementation? But do you need multiple implementation? I argue probably not, because you have the 7 days, you have security console, right? If there's a bug, you can fix it fairly quickly. You can resolve that offline, right? And then do you need multiple node runner? I argue probably not. You need 1 active validator, and then you need 1 defensive validator, and you just need 1 of them to be honest, right? So it's all about trust at the end of the day, right? So layer 2 is a very beautiful like beast, because like it allows us to essentially have less trust, right? So this picture was captured from Vitalik's article back like 2 years ago, where on layer 1 we're kind of at the opposite side of the triangle where we need n of 2, right? But for layer 2, we're more on the bottom side. We just need 1 of n or phi of n, and that's all we need. So I think like this is the point of this talk, right? This is probably the most important slide that I want to get to, is that we should leverage layer 1. We should not copy layer 1, right? Layer 1 is fundamentally very different than layer 2. And then if something works well on layer 1, it doesn't mean it will work well on layer 2. I mean, I have seen thread that like, for example, that people say that, hey, proposal builder separation MVP boost works well on layer 1. It's maximum decentralized. Let's copy MEV boost and put it on layer 2, right? But then you also have another problem, such as front running. You have toxic MEV, and then it's got its own principal agent problem, right? And base layer sequencing in the current form also doesn't really make sense, right? Because now it's also very slow. So you're back to the 12 slot time. So this is probably the most important point that I want to make. It's just that like layer 2 should not copy layer 1. Layer 2 should use layer 1. So I just inserted a few pictures. This is what layer 1 looks like today. We hope layer 1 to look like that, right? So it doesn't make sense to build the entire same infrastructure you're building on the left picture to the right picture. So why am I bullish on layer 2, right? So this is a couple of things that I have been thinking on how layer 2 could better use layer 1 in the few months or in the next year or two. So layer 1 has to make this trade-off, right? You have this scalability triangle that Vitalik made famous of, right? You can only choose the 2 sides of the triangle. You either have scalability and security, or either have security decentralization, right? You have very high performance chain. I don't want to name. They're very scalable, but they're not decentralized. Versus Ethereum, we're kind of on the bottom side, right? We have this security, we have decentralization, but we're not scalable, right? So layer 1 has to make certain trade-off, but I don't think layer 2 has. So please hear me on that. So I think layer 1 will supercharge layer 2 in 3 different areas: scalability, security, decentralization. And I will show you why I think so I will show you why. So the first is data sharding. So EIP 4844 is coming this year. So this is where we switch code data to blob data. Yeah. And then we should have 32 kilobyte. That's basically free. 64 kilobyte And then once you reach that, the gas will increase, people will pay more. So at the very conservative estimate, I can see L1 data reduction to be 3 to 10 times lower, right? And then into 3 to 5 years, my very conservative estimate, we should have dank sharding, which is very super blob data via data availability sampling, right? So we should also see another increase of layer 1 data. So layer 1 is ultimately like heading to the direction to support layer 2 to have very cheap data. So scalability is basically solved there. The second one is security, right? So I want to talk about how layer 1 made the security better for layer 2. So as it turns out, when we switch from proof of work to proof of stake, reorg means block can be seen on chain. So we can actually use that as an advantage, which I will cover later. And then also in proof of stake, there is also economic finality, which is nice. Validator are attributable, so you can socially slash them. That's also nice. And then you just have superior censorship resistant probability with the proof of stake network, which I will go over in the next slide. Okay, so there is something called a faster confirmation rule, because right now Ethereum is finalized every 6.4 minute. So with the faster confirmation rule, that what we're working on is that we're basically willing to make certain trade-off that we say that, okay, assume less than 1/3 of the network is non-malicious, and then assume that if they cannot get slashed if they do reorg, or I mean, you could social slash them, then you can have less than 1 minute latency to confirm. So this is kind of like finality, but this is kind of the probabilistic finality that Bitcoin loves, basically. And then so essentially you have 1 minute to confirm. So this will essentially speed up the layer 1 to layer 2 message. So imagine you send a message from layer 1 to layer 2. If you use this fast confirmation, it should take less than 1 minute, probably 24 seconds. So I'm very excited about that. The other one is layer 1 on-chain censorship oracle that Ed and a few others have been thinking, right? So sorry for the bad format for the formula. So you can have a heuristic on-chain, basically you just count missing block over the last period, right? For example, you make assumption that 10% of the validator are honest, which is very conservative, I would say. And then you basically say, okay, if today we have 4 missed block, if we have less than 4 missed block in the last 225 slots, which is 45 minutes, then we can safely assume there is no censorship, right? So this allows fast layer 2 to layer 1 message, for example, withdraw. So this is something that's also very exciting. And then there's also single slot finality that is also coming. It may not ship until 2025, but now we can finalize every 12 seconds. So with finality every 12 seconds, there's so many cool things that people can do with it. And then they're on the decentralized. So I went from scalability to security, but now I will talk about decentralization. Yeah. So the statelessness is coming, where we're switching from local tree to local tree. So this new structure will allow to reduce the state size when you run a node. So in this case, running a layer 2 node will become a lot more accessible. So you can run a layer 2 node on your Raspberry Pi, hopefully, and then you validate the data using witness. And then there's currently the 2 testnets up and running on the layer 1 side. So hopefully we can get Arbitrum to try that soon. Then there is this bonded historical data. So this is very interesting. This is EIP 4444. Basically, it caps the data. So saying that I only need to store 1 year of data, right? Because for Ethereum, right, it doesn't make sense to be like long-term storage. What we want is a decentralized bulletin board, basically. And then essentially say, we only store 1 year of data, and then layer 2 can adopt that as well, right? So therefore, to running a node is going to be cheaper. Right, so finally, I think layer 2 in the not-so-distant future, right, we should have scalability, so which cost reduction 3 to 10 times. We should have better security, meaning the faster layer 1 to layer 2 messaging using the fast confirmation rule. Also faster layer 2 to layer 1 message using the on-chain oracle, and so withdrawal will be faster. And finally, we have decentralization such that running a layer 2 node will become more accessible. And then also layer 2, also what's the beauty of layer 2 is layer 2 also has its own open innovation, right? So it uses layer 1, but it does more. For example, EVM plus that stylus that Rachel is working on, we can have basically Watson equivalents aside of EVM equivalents, right? We can implement our own privacy. We have our decentralized sequencing. We have communication strategy, and we have layer 3, layer 4. We can keep extending on that, right? So to me, layer 2 is probably the golden age of layer 2. Just like there's so much we can do. And then because that we can actually hit scalability, security, and decentralization, we can hit all 3 points. Finally, right, like what we do is essentially up the audiences here, right? It's like I want feedback on like what can the layer do more to support you guys, and what can we do basically if it's any feedback, if anything that you want to build, you cannot build because of you missing certain features. On the EVM side, I would like to hear more on. So yeah, that's it. That's my talk. Thank you for bearing with me. And yeah, I hope that you are as bullish about layer 2 or Arbitrum as I am. So yeah, thank you. Enjoy the rest of your day.